to algebra with classifying parent functions. All right, so classifying is identifying what they are. Parent is a like a main function, right? And then a function, well, if you can't remember what a function is, let's talk about what a function is right now. Okay, let's say I have a do thing box, right? And then this box does something with an input, right? And then after the input, after I put something into this box, it provides one output. Okay, so this box in math is called a function. Okay, and how we show that is, say we have f sub x is what we call a function. So if we have, for any value of x, it would spit out a y value on a coordinate plane, like x and y, right? So here's a pretty easy example, right? Let's say that f sub x, or you can just say y equals same thing, right? F sub x can be y equals, right? And you can just say my function equals, and we'll just say we'll say 3x plus 2. 3x plus 2. Okay, and so if I say that my input for x being my input, right? X is my input, right? We'll say x is 5. Say x is 5. So it's going to be, this is going to be equal 3 times 5 plus 2 equals 15, equals 15 plus 2, which equals 17. All right, so that is what a function is. Like I had, this was my function. I had is 3 times x plus 2. This was my function box. 2 or 5 was my input. It spit out 17 as my output. Okay. Now y can be represented by f sub x, as y is a function of x. So that's what they mean by a function. Okay. So like a really easy function, like one of the easiest functions is saying that, hey, y equals 3, right? That means that, like, if I go 1, 2, 3, right, my y value equals 3 no matter what x value I put in, right? It's a straight line all the way across, right? It's, it's technically a function, but no matter what I put in there, there's no x value, right? Because there's no x value, my y value is always going to be equal to 3. Okay? And then conversely, x equals, we'll say 2. This is my x value, and this is my y value, and we'll say that this is 1, 2. Well, I don't have a y value for this, technically. Right? My y value, I have an infinite amount of y values for this, right? Because it goes all the way up and all the way down, and just this line happens to intersect at 2, right? So no matter what value of x I put in, I have an infinite amount of y values, right? So that's just talking about functions, okay? And these are like two pretty basic functions. A straight line for wherever it crosses the x-axis, that's a x equals 2, and if it crosses the y-axis, it's y equals whatever value it crosses the y-axis at. Okay? So let's get into some algebraic functions that we're going to be seeing here pretty pretty often. Okay, well, we're gonna see something like a quadrat, or we'll start with linear. A linear. I mean, these are linear. These are straight lines, right? But this one has no slope. There's no slope. This one has an infinite slope, straight up and down, right? A slope again, right? Slope. You may remember, we might get to this as your change in y divided by your change in x, right? So my change in y in this one is 0 over my change in x, which was 0, so 0 over 0. My change in y in this one is 0. My change in x is 0, so if you have a 0 in your denominator, it's going to be infinite. Okay, it's still, either way, it's 0 over 0. Okay, I guess technically that would be a 0 as well. All right, but either way, say I have a line that is something like, let's say it's like this, right? We'll just go right through the axis, just like that. And we'll say for every, change in y is 1, and the change in y equals 1, and the change in x equals 1, right? So, by the way, that little triangle, if you didn't know, that delta is a change in, I don't know if you guys learned that before, but that's what that delta means, right? So the slope is 1, right? Slope equals 1 divided by 1, which equals 1, right? Well, anyway, this is the line y equals x, right? That's a linear line, and this is that parent function, right? I don't know if you guys have gone over your point-intercept form, which we're going to go over, I think, later in the year. But, if you shift this line up or down, right, you would add a y-intercept to wherever that, say I wanted to shift it 3 up, I would just be plus 3, and this thing would shift it up 3. Okay, but it starts at y equals x. Right, that's my parent function for a linear line. Okay, if it went down like this, if it went like this with the same slope, right, it would be a negative. If for every change in 1x, right, it would be a negative 1, right, negative 1. So it would be a negative slope, right? So it would be y equals negative x, right? So that's a little bit different there, okay? So that's a linear function. All right. Next, there is a quadratic function. Okay, so a quadratic function is something like y equals x squared. Right, and so because of this x squared thing, say I have like a 0 squared, my input for x, say x equals 0. Well, 0 squared, so x equals 0, x squared is 0, right? If x equals 1, right? Well, so this will be my x value. Make this table a little bit better. Okay, so this is x. There we go. X squared, well, x squared is 1. What if x squared is negative 1? What if x is negative 1? Well, x negative 1 times negative 1 is 1. Right? And it goes on for that, and then it goes on for that too. So what if it's 2? Well, 2 squared is 4. Negative 2 squared is 4. Right? So it doubles, it gets progressively bigger. Right? So let's look at the positive side. So we'd have a 2. Let's just go like 1, 2, 3, 4. Right? It would go like this. Okay, 1, 2, 3, 4. So it would be like right here. Right? So it's gonna. So if x is 2, 4 is going to be here, right? So it's going to change exponentially, kind of like that. But not only does that do it on the positive side, but it also does it on the negative side, because no matter what value of x that I put in, because no matter if I multiply anything by itself, whether it's negative or positive, if I square anything, no matter if -4, -3 squared, it's going to be positive. 9 squared, -9 squared, it's going to be positive. When you square a negative, it's always positive. Okay? Unless we're dealing with complex numbers, which is way in your future, you cannot square a number and have a negative value, which is why there's nothing down here. And this is quadratic. Quadratic. So you might ask, why is this called quadratic? Well, it comes from a Latin word, quadratum, which means square. Right? Quadratum. It's Latin. So that's why that means that. Helpful information if that's helpful. It's a little maybe extra stuff that might not be helpful. But anyway, okay, so next we have a cubic function. All right, a cubic function. Cubic. All right, we have a cubic function. Let's make our table again. We have our x, and then we have an x cubed. Right? We'll have a 1, and well, of course, 0. We don't have to do 0. It's going to be 0. Okay? And then we have a 1 and a 1. 1 and a negative 1. Right? Oops. Let's make that a 0. Okay, well, 1, no matter how many times. Okay, 1. Let's just do this. Okay, 1 to the third equals 1. Awesome. 1 negative to the third equals, hey, -1, because -1 times squared is 1 times -1 is another -1, right? So we're going to have negatives for this. Let's do 2, right? 2 to the third. 2 to the third is 8, right? So my x value gets big fast. Right, my x value gets pretty big, pretty fast. For every value, sorry, my y value. My y value is going to get pretty big, pretty fast for every x value that I put in there. Okay, so these are going to be big. These are going to be y's. It's going to be a logarithmic scale, right? But let's look at so -2. I do. To negative is going to follow the same pattern as the -1. It's going to be 8, but that 8 is going to be negative, right? So we are going to have negative values, and it's going to be pretty similar on the right hand side as a, I guess it doesn't go straight up, as exponential, right? But it goes up a lot faster. But on the left-hand side, it's kind of like symmetric in the quadrants from this quadrant to this quadrant. It like reflects from here to here, right? Because we have -8 on this side, right? So it's gonna look like that over here. Okay, so my y value, if it's -2, it's going to be -2 down here. It's going to be -8 all the way down here. Okay, so that's what my cubic functions look like. And it's cubic because my function is cubed. Remember, and if I add a y value, this would shift up. If I added an x value, this would shift over one way or another. Okay. All right. Moving on to, where'd my note cards go? Oh, here they are, maybe. Let me pause real quick while I locate my note cards. They fell on the ground. I located it. All right. So now let's go to a cube root function. Right? A cube root function. So a square root function is kind of like, oh, no, let's do a square root function. So a square root function or a radical. Okay, so x So y equals the square root of 3, or we'll do 2. Square root of x. Square root of x. Did I make that clear on the other ones? I don't know if I did. All right, so this would be, so this cubic one would be like y equals x cubed. This one would be y equals x, yeah, and y equals, yeah, okay, yeah, I did that, I just forgot to do y equals x cubed. Okay, this one would be y equals x to square root. Remember, this is like with a 2 up here, right? Like that. Right, this is like square root. Okay, so you can put, again, if we kind of like make our table, if my x value is my input is this, right? What would my y value be? Okay, or my square root of x, right? What is my square root of x? Which is y, right? That is y, right? So x is 1. 0 is going to be 0, right? 1 and then negative 1. Okay, well, let's take a look here. Something interesting happens here. Okay, well, square root of 1 is 1. Okay, if I do 1 with the square root, and I get 1. What happens if I put negative 1 and no 1 negative and I put square root? It says error. Well, that's weird. Well, I can't take the square root of a negative number because there's nothing that I can square that would give me a negative number, right? Kind of like we were talking about earlier on here, right? There's no negative number that I could square that would give me something that take a square root of, right? Because remember, the opposite function of square rooting is squaring, right? So this is undefined. Undefined. Okay. Okay. So then we have, let's do 2. Well, let's do 4. Let's do 4. So if we do 4 here, it's 2. Okay. Again, if it was negative 4, it'd be undefined. And if we did, let's see, 6, let's do 9. And it would be 3 here. Okay, so what we would have is for an x value of 1, it would be 1. For an x value of 2, it would be like, y would be 4. 1, 2, 3, 4. Y would be 4. And then for x value of 3, y would be like way up here at 9. Right, so it looks something like this. Like that. It's kind of, this is my x, this is my y. It's kind of like my quadratic equation, but on its side. You see that? It's kind of like my quadratic equation, but on its side. And it's only in one quadrant. It's only in one quadrant. Okay, because of the whole no complex number thing. It's only in one quadrant. Okay, so this is square root function or radical or square root. Radical square root 2. Okay, or not square root 2. That's not right. Radicals. Second root. Okay, so then we have a cubed root. Because we did the cubics, we did a cube root. Okay, so this would look like y equals cube root of x. Okay, and it would look because let's do you might catch on here. Let's find our cubic one. You know, it might be a little intuitive that it might look something like this, maybe a little something like that, but let's take a look. Okay, let's make a little table here. So if I have my x equals something, what would my output be? Cube root of x. Right, so let's say that let's start with 1. Do 1. We'll do negative 1. Well, what's the cubed root of negative 1? Well, let's do 1 negative. Let's do the, how do I do cubed root? We'll see this one. The cubed root. I gotta go second 3. That's the cubed root. It's negative 1. I have a value for that because 1 times negative 1 times negative 1 is 1 times negative 1 is negative 1. Let's do 8. Let's do 8. Well, the cubed root 8. The cubed root is 2. Let's do negative 8. Negative 8 to the cubed root is negative 2. Okay. All right, what's another cubed root? Let's do, what's 3 cubed? 27. Okay, let's do 27. 27 and then negative 27. Those are 3 and negative 3 respectively, right? So it would look my 1 and 1, and my 8 and 2, and 27's way over here, so it would look something like this. And this would look something like this for my x and y axes, right? So it looks kind of like that, but like if I could flip it over, kind of like that, right? So that is what your cubed root function looks like. This is the cubed root function. Okay, so that's what that one looks like. Then we have an absolute value function, right? So absolute value, so y equals the absolute value of x, right? So if I had a x and then the absolute value of x, right? 1 and 1, negative 1 is 1. Negative 2, it's 2. 2 is 2, right? That's the absolute value. There's never going to be anything negative, but it's a linear relationship, a one-to-one relationship. So we're not going to have any curves. It's going to be just like a nice looking V shape, right? Linear relationship, very similar to what our linear relationship looked here, but nothing will ever be negative. It'll just be effectively that, right? If I put a negative sign, the negative absolute value, oh, where'd it go? Where'd it go? Is it in my hand? Where did I leave it? There it is. Okay, if I made it like the negative, if I made it the negative absolute value like that, then it would just be like that, right? But that's not what I put. That's not the parent function. The parent function is like the bare minimum. Okay, so I'm not going to do that and confuse you. Okay, the parent function is just like y equals x, right? So that's the linear function. It just looks like a V. No curves, straight lines. All right. Then we finally, the last one, I think it's the last one. Yeah, the last one is an exponential function. Okay. 2 more. We have 2 more. Technically, it's an exponential growth and an exponential shrink. All right, so I'm going to do one on one side and one on the other. I didn't have enough made up. So where'd my blue go? I'll make it. I'll do this a little different. I'm going to do one here. One like that. I'll do it all in the same one. Why not? Because they're kind of similar. Okay, so I got one here, and I'm going to do an exponential growth. Right, so my exponential growth looks something like this. We'll say it's this is my x, and this is my y. Okay, and I'll say my x. I'll do this in. Sorry, my y value. My y value equals. We'll start with, we'll say 2 to the x, okay, where my exponent is my variable, Okay, and then I'm also going to go down here in my red one, and I'll say that y equals 2 to the x. So I'm going to plot two graphs on one here, two parent graphs on one. Okay, so my x and then my 2 to the x, which is my y value, right? And up here I have my y and then my 2 at x, and we'll see what happens. All right, so let's say this is 1. We'll say 2, 3, and 4. And we'll say 1, 2, 3, and 4. Oh wait, this is wrong. This is wrong. It's the same thing. This is supposed to be, excuse me, this is to the 1/2. This is 1/2. This is the shrink. 1/2 x. There we go. This should be 1/2 x. 1/2 x. There we go. All right, so now we're all set up. So let's calculator this and see what happens. Okay, so if I go 2 to the 1, it's 2. If I go 2 to the 2 equals 4. If I go 2 to the 3 equals 8. Okay, and if I go 2 to the 4, it equals 16. Okay, so I'm going to do my x equals 1, 2, 3, and 4, and then this would have been equal to 1, 2, 3, 4, 5, 6. It's going to be, let's see, 1 and 1. Okay, so, oh, sorry, this is 1 and 2. This is the wrong point. 1 and 2, and then 2 would have been 4 right here, and then 3 would have been like 8, which is way up here. So it's going to be like a real quick growth like that. Something like that. Okay? That is a real quick growth. It went off scale super fast. Right? And it actually approaches more like a... What happens if this thing gets... if I make x 1/2? What if I do 2 to the 1/2? Well, it's 1.4. Right, it's still positive, but it's 1.4. So it's like right here. Okay, what if I made it -2? Right? So 2 to the 2 negative, well, it's 0.25. So it's 0.25 here. It's 2 to the 0. 2 to the 0 is 1. So this should have been intercepted at 1 here. So it's actually going to look something more like this. Okay, is it ever going to be, can I ever make this thing 0? Right? Can I ever make this thing 0? 2 to the, I don't know, 1/1000ths, 100. It's still 1. It's going to be approaching 1, right? Because I can't go, if I go 2 to the negative, 2 to the negative 3, oops, 2 to the 3 negative, it's 0, right? So it's going to approach, this isn't truly 0, but it's going to approach 0. So it's going to look something like this. Erase this part right here. So it approaches 0, but it never truly reaches 0. It approaches what we call an asymptote at 0. Okay? So that's what that kind of looks like. All right? So what about this 1/2 x? let's do something like 1/2 to the 0. It's going to be 1/2. Right? So if x is 1/2, then my, if x is 0, then this is going to be 1/2 to the 0th. This is going to be 1. Right? So that this is going to be 1 right here. Okay? Well, actually, right here. My x is 0. So what about if x is 1? 1/2 to the 1st. It's going to be 1 right here. Like right there-ish. What if I do 1/2, 1/2 to the 5th? 1/2 to the 5th. It's going to be, okay, it's going to be like way down here. It's going to be approaching 0. Okay? What if I do 1/2 to the -5th? Well, it's way up here. It's at 32, way up here, right? So you can see that, oops, I fell off the page. So this one kind of does this. It approaches 0 from the other way. It is a negative growth. It shrinks and approaches 0 in another way. Now if I added like a +2 or whatever, and like a +2 over here, it would shift these lines up. And then 2 would be your asymptote, right? Asymptote. It's one of my favorite words. All right, well, that was a long lesson. We'll get to that. And if you have any questions about that stuff, let me know.